how to convert from decimal to octal. So as you know, decimal is a number system that we commonly use 1 to 10. Similarly, there's a number system called octal. It uses 1 to 8. Okay, just like binary uses 2, octal uses 8, and decimal uses 10. So that's how they are related. So let us see how we can convert a number to octal from decimal. This is the next step. So this is the starting. So what we do is we have a decimal number 1792, nothing interesting about that, just simple number. What we have to do is divide it by 8. Then we get a quotient, right? Now quotient will keep it aside because quotient will not give us anything immediately. We'll use it in the next step but not in this step. Now we get a remainder. What is the remainder? After dividing by 8, is there anything that is undivisible part? You guys know obviously remainder, what a remainder is, or you can understand it better using another video. So here we got remainder 0. Now this forms the last digit of the octal number, not the first digit, but the last digit of the octal number that is going to come out of it. Now let me go to the next step. In the next step, we use the quotient. What is the quotient? The one that we got the result of the division. Now we use the 2 to 4 quotient here in the next step, and then we divide it by 8. Again we get a quotient and a remainder. Obviously every division will produce these two results. Now this will form the, I guess there's a little mistake. It should have been, sorry about that, this should have been 2 zeros. Can I edit that? Yeah, okay. Oh, I guess it doesn't take it. So yeah, basically it's like this. There are 2 zeros. So we got the last 2 digits of the number that is going to be generated. Okay. Now this is not taking it for some reason. If I click away, it is becoming 1 0, but it should be 2 zeros. Okay. Now let me take you to the next step. In the next step, we again use the same quotient and divide it by 8. Now this time we get a quotient obviously, but this time we get a remainder also, which is not 0, because 4 more is there, which is not divisible by 8 because it is less than 8. Okay, so what happens is this gives us the third digit. So every step will give us one digit. So this gives us the third digit of our, third from last. Okay, not the third from first, third from last. Okay, it is all the digits are going from last to first. Okay, so this is the last, this is the second last, this is the third last. Okay, then let us go to the next step. That is the final step. How we will know that it is the final step? Because the quotient is 0. Basically the number that we are dividing by 8 is less than 8, so more division is not possible. So quotient is 0 and the remainder is obviously 3 only. So we get 3 as the first digit. Okay, so if like 3 was something, say even bigger than 8, like 13 or something, there would have been one more step, but this is at the end because 3 is less than 8. So once the number becomes less than 8, the quotient becomes less than 8, like here, you will know that the next step will be the last step. Okay, so we got that as 3, and in fact you don't even need to write or do the last step, because obviously from the quotient only you'll know this is less than 8. You can directly put it as the first digit of the number. So finally what you got is 3400. Now even though this looks like decimal, this is octal. Okay, because what is the difference between decimal and octal number? Not much of a difference, because by looks, because it will still use the same digits, but only difference is that octal number will never be greater than 8. Okay, so you will never see 99400, because 9 will never be present in octal number. However, that will be present in decimal like it is here, but that will never be present in octal number. So that is the difference, and that is how you can do it. Okay, thanks. That is the end of the video.